Hi, in this Let's Create series we're creating the classic block breaking game of Breakout. In the last episode we set up our scene with all the blocks and things, and in this episode we're going to focus on getting the paddle and ball mechanics working. Let's get started. So we've started from where we left off last time. Let's create a scripts directory, and with the right click menu create a new C# script which we'll call Game Manager. To the scene we'll add an empty game object called Game Manager which we'll drag the script onto. Now time for some coding. We'll start with the movement of the player's paddle and the ball, so let's get references to those. The ball is a private serialized field of type rigid body 2D called ball. The serialized field attribute enables us to assign this in the Unity inspector, and we get the rigid body 2D as we only care about setting the physics on the ball. For the paddle we get the transform, as we'll be moving that directly. I like to keep the variables in the inspector organised, so I'll add a header to these called Unity objects. We'll control the player interaction in the update method, which is called every frame. For the player movement, we'll get the direction using the input.getAxis and passing in horizontal as our axis. This means that you can use the left and right arrow keys. Left will get negative value and right a positive. Let's add a new header to our global variables called game parameters, to which we'll add a serialized private float called paddle speed, which I set to 4. We'll use this to control how fast the player moves. So in our update, the move amount is defined as the direction multiplied by our paddle speed multiplied by time.delta time. Time.delta time is the time elapsed since the last frame. This means that you move at a constant rate. We can then move the paddle using the translate method, passing in our move amount multiplied by vector2.right, as we need a vector, and that will make the y value 0. We want to make sure that our player paddle stays in the game area and doesn't go through the walls, so we constrain how far it can go. If the paddle position in the x-axis is less than -5, which puts the paddle about where our wall is, then we set the paddle position to be a new vector2 with x exactly at -5 and keeping the same y position with paddle.position.y. We can do exactly the same thing for the right side by comparing if it is greater than +5 and setting to this. We'll check this out in a moment, but let's get the ball moving so we've got some reason to move. There are 2 states for the ball. Before it's launched, it's stuck to the paddle. Afterwards, it's bouncing around the screen. So we'll add a new private bool called isBallInPlay, which will default to false. In our update method, if the ball isn't in play, the exclamation mark reads as not and negates the boolean. You could equally do isBallInPlay == false. Then we stick the ball to the paddle. The ball reference is to the rigid body, so we can access the position with ball.transform.position, which we set to the paddle position plus a small amount to make it sit above the paddle. I used vector3.up times 0.2, which essentially sets x =0, y = 0.2, but is simpler than constructing a new vector2. When in this state, we want to wait for the player to fire the ball. We use if input.getButtonDown with fire1 as the parameter. This means that when the user presses fire, which on the keyboard is left control, this code will execute. We set isBallInPlay to true. This means it'll no longer hit this loop and be stuck to the paddle, and add a force to the ball using addForce. The first parameter is the force to add. For this, we'll add a new global parameter to our game parameters section, which is a serialized private vector2 called initial ball velocity, which I set to x = 2, y = 4. This will make it go up and to the right. We can then pass this to addForce, and the second parameter is the mode, which we use forceMode2D.impulse, as we only want to apply this force once. Let's jump back into Unity to check this out. We need to select our game manager and add on the references to the paddle and the ball. You can just drag them both in. Start the game by hitting play. You can see that as I use the left and right arrow keys, the paddle is moving correctly. Remember, because we serialize the game variables like the paddle speed, you can adjust this in the inspector if you want to balance this differently. We can't go off either side, and when we press left control, the ball is launched. Oops, looks like the ball isn't behaving quite like we wanted, it just seems to have disappeared. If you look at it, you can see that it's falling away into oblivion. What happened there was twofold. Firstly, it's being affected by gravity, so it fell down, and secondly, the collision detection didn't actually work to keep it in the game area. Let's fix those two things. On the ball, let's remove the angular drag. The angular drag affects the rotation of the ball, and it shouldn't be rotating, so we definitely don't need that. Next, we can remove the gravity scale. We don't want the ball to be affected by gravity, it should just bounce around as if it was in a vacuum-like space. We also set the collision detection to continuous. This does a more accurate collision detection. With discrete, a fast-moving object can pass straight through an obstacle if it's going fast enough. In games like this, performance isn't key, so having continuous avoids all possible issues for negligible performance drop. Let's try that again now. Now it's flying away, but it isn't very bouncy. It loses its speed when it hits other objects. This is because of the friction being simulated between them. This is one of the drawbacks of using the physics engine. There's a lot of variables can and does apply by default. So to counteract this, we need to add a physics material. Create a physics material folder, then right-click, create 2D, physics material 2D. Here we can set the friction to 0 and the bounciness to 1. This will mean that when an object hits this, no energy is lost and it will move in the opposite direction with the same speed. Then you can drag this onto the material property in the rigid body 2D. That's working much better now. For me, the ball is bouncing around the screen successfully. However, when I prototyped this, I found that the ball was getting stuck at the walls. If you have this problem, then we need to update a setting. If you go to Edit, Project Settings, and click on the Physics 2D tab, you can set the velocity threshold. If the velocity is below this, then the collision is considered inelastic and it will not work as expected. So just to be safe, we'll set this to 0. That's it for this episode. In the next episode, we'll make it so you can actually destroy the blocks. As ever, the full code is in GitHub and linked in the description below. See you next time.